Alright, so we've mastered asynchronous code and event-driven architecture. Now, we'll combine those concepts to tackle one of the most important and powerful features in Node.js, which is streams. So this is how Node handles large amount of data like a big video file or maybe a real-time network traffic without really without crashing. Now, just to explain what is a stream, let's say for example we have fs.readFile. It tries to load the entire 2 gigabytes file onto your computer's RAM all at once. So this is called buffering. So if you don't have enough RAM, your application will slow down and it's likely to crash. So this is incredibly inefficient. Now you don't want to download the entire 2-hour movie before you could start watching it, right? So you watch it as it streams to you, right? Now Node.js can do the same thing with data. Now what is stream? A stream is a sequence of data that is moved from one point to another over time. So in a small manageable pieces called chunks. Now instead of reading the whole file into the memory, you can open a stream to it. So the stream will read the first chunk of the file, let you process it, then read the second chunk, let you process that, and so on until the entire file is read. So this way you only ever have one small chunk in the memory at a time. Now streams are built on the event emitter. So remember the event emitter class, we learned about it in the last lesson. So they emit events like data when maybe a new chunk is available, and then end when the stream is finished, and then an error. So there are 4 main types of streams in Node.js. There's readable, a stream that you can read data from, for example reading a file, and then a writable, a stream that you can write data to, like writing it to a file, or a duplex, a stream that is both readable and writable, maybe let's say a network socket. Transform, a special duplex stream that can modify data as it passes through, maybe a compression stream. Now the goal is to create a script that reads large file.txt and then compresses its content on the fly, and then writes the result to a new file called whatever we're gonna think of a name. So we do this using the power of streams, ensuring that we never load the whole file into the memory. Now imagine an assembly line. You have a part at the beginning, meaning the reading stream, and then a box at the end, so the writable stream, and a pipe is like the conveyor belt that moves the part directly into the box, and then a transform stream is like a station in the middle of the conveyor belt that changes the part as it passes through, for example maybe a robotic arm that paints the part red. So in our project we will have a readable stream, which is like a large file text, and then we're gonna use we're gonna transform the stream. So that is a Z library compression stream that paints the data by compressing it, and then we're gonna have a writable stream. Node.js has a built-in module called zlib, right, that provides compression and decompression tools. Crucially, it just gives us access to transform streams that we can place right in the middle of the pipe chain, right? So we're gonna build it. So let's go ahead and build it. So in our directory we will create a new file called it's called compress.js. And then let's go ahead and open that file. Now I'm gonna import fs from, and then we import we're gonna first create a readable stream from our large source file. This will read the file chunk by chunk, and then we're going to create a writable stream to our new compressed file. So this will write to the file chunk by chunk as well. And then we need to create a zlib transform stream. So it will just take the data, compress it, and then pass it on. And then we just need to use a pipeline function to connect everything. So pipeline is actually great because it handles errors and clean up for us. Or else so we can just say maybe a new file, large file .txt.gz has been created. I think we must actually go and create that file probably somewhere here. So we can just say const file is fs.create. So let's call it large file.txt, because now we don't have that file. We're gonna use a loop to actually write something in that file. I is 0. Maybe we can just say console.log large file created, generated, successfully. Now we can go ahead and run compress.js. Alright, so we do have the large file.txt. You can actually see it was created, and then there is the compressed file. Alright, so the most amazing part, now if you look in this folder here, you'll find that we've got that large file.txt, and then we also have the large file.txt.gz. So if you compare its file size to the original large file.txt, you'll see that it's significantly smaller, and then meaning we've successfully compressed the file. So the most amazing part is that Node.js process used very little memory to do this. Even though the file was large, it read a chunk, compressed the chunk, and then wrote the compressed chunk, and then moved on to the next one, all in a beautiful and efficient flow. So that is the power of just chaining streams. Alright, so now let's actually go and look at these two files. I'm going to just reveal in the Explorer, and you can see the file size is like about 7,998 kilobyte, okay, of that file. And if we look at it, we have just something weird, like this. Oh, sorry, something weird like this. All right, like 100,000 times. So this line is 100,000. We have 100,000 of that line, so which makes it a huge file. And then we've got the compressed. Why is it 0? Let's just see. Okay, so here So we had this error here. Okay, so let's go ahead and comment out this line. So we're gonna just comment out this line, and then just make sure large file.txt and let's just delete this one, the compressed version, and then let's run it again so that we can reproduce that error and see what is the problem. Okay, now it actually everything worked fine. So let's just look at compare the sizes. You can see now the sizes is smaller than the original size. So that's just the amazing part of Node.js. And again, we use a very little memory to actually compress that file.